Hello everyone, welcome back to my YouTube channel. So in the previous video, we have discussed basically, the rules and the types of questions which will be forming. So if you haven't seen, do watch that video. I have talked about all the theories, right? What is permutation, what is combination, and all the cases. Now in this particular video, I'll be solving the questions related to whatever concepts we have discussed in the previous video. So let's begin. Let's see the first question. So the first question says, if there are 6 people and we are given with 6 chairs, all right, 6 chairs are there. So how many arrangements, how many arrangements are possible? Okay, so this is the first question. So as we can see, people are always different, isn't it? So this is what the concept is. When I talk about the people, people will always be, they will always be different. All right. So now 6 chairs, chairs will be identical, isn't it? Chairs will be identical. So whenever you get people, children or men, women, something like that, do consider people as n different things. So now 6 people are to be seated, right? So arrangement is given. That means it is permutation. So what is the answer? 6p6, which is nothing but 6 factorial. I hope you understood this question. Okay, perfect. Now moving on to the next one. Let's see what it is. So next question says, basically now again, 6 people are there. Okay. And there are basically, uh, let's say 8 chairs are there. 8 chairs. So now in how many arrangements, are possible? Okay. So now this is a question again based on basically 8 chairs are there and 6 people are to be seated on 8 chairs. So all 6 different people are to be seated on 8 chairs. An arrangement is given, so it's a question of permutation. Therefore, what will be the final answer? 8p6. Right. So 8p6 is nothing but 8 factorial divided by 8 minus 6 factorial. I hope you are getting this. Is equal to 8 factorial divided by 2 factorial. Okay, so 6 different people and 8 different identical chairs are there, right? Sitting arrangements can be made out of 6. So 8p6. Clear? Perfect. Moving on to the next question. So let's see the next one. So next question is about, let's suppose we have again 6 people. Let's consider all these scenarios. Okay. And now again 6 chairs are there. Fine. And 3 men and 3 women are there. So 6 people, such that out of them, 3 are men and 3 women, and 6 chairs are there, and they have to be seated. Okay, they have to be seated. So now, basically, we have 3 men and 3 women. Okay, and they must be. So I'm giving a condition: seated, alternate to each other. Okay, so they must be seated, alternate. Right. So how many ways are possible over here? So let's analyze this particular scenario. So what is given to us over here? We are given with 3 men, all right, and we are given with 3 women, and out of that total 6, 3 men and 3 women. So now it is saying that men and women should be alternate to each other. So I can draw 6 dashes like this, 4, 5, 6, and then now I can fix the position of men, right? Here people, so all the 3 men will be different and all the 3 women will be different, and therefore I can say, if I fix men 1 here, men 2, and then men 3 over here, right? So naturally, the remaining spaces can be filled by women, isn't it? So women can take place over here, women 1, women 2, and women 3. Fine. Okay, now second scenario could be I could also place men starting from the second place. So M1, M2, and then M3, right? And similarly, I could put women in the first place, women in the second place, and women third over here, right? So there are basically two cases, either this or this. So I have to add them, isn't it? Now, since all the men, all the three men and three women are different, so this can be done in how many ways? 3 factorial into 3 factorial. Why multiplication? Because first men are getting filled, okay, and then women are getting filled. So this will also be 3 factorial times 3 factorial, isn't it? So this becomes how much? 2 times 3 factorial times 3 factorial. I hope the concept is clear to you. Okay. Now moving on to the next one. Okay. So let's see the next question. Next question says we have to arrange. There is this word called as begin. Okay. So that, you know, so that the words start with, I'm giving you the condition, so that the words starts with a vowel, starts with a vowel. Okay. So now how do we do this question? So we are given that arrange, right? So again, permutation, so that it starts with a vowel, right? So again, I'll put dashes 1, 2, 3, 4, 5 because 5 letters, 5 alphabets are there. 1, 2, 3, 4, 5. Now, how many vowels do I have? I have two vowels, right? E and I. That means to start with a vowel, I can fill this place in two ways, isn't it? And then if one is already filled, okay, how many are remaining out of 5? 4 are remaining. Then this can be filled in 3 ways, and then this can be filled in 2 ways, and then this can be filled in 1 way. So the final answer is 2 into 4 factorial. So 4 into 3 into 2 into 1 is nothing but 4 factorial. I hope it is clear to you. Okay, perfect. Now moving on to the next question. So these are the basics and conceptual questions which will build your basics. So do try these questions on your own as well. Next question is arrange, you know, it is saying arrange 5 different paintings, so that the best and worst are together. Okay, so we are given with 5 different paintings so that the best and the worst paintings are together. Now let's try to understand this. So how the solution goes. So we have total 5 different paintings, right? So I can say the best and the worst, they are together. Okay, and the remaining 1, 2, and 3. Right. So 4, 5. Total 5 are there, and they are together means they'll be acting as one unit. Okay. So they are together. So they themselves can be arranged in now 4 groups we have, right? One, which is together, worst and the best scenario, and then 1, 2, 3. So we get total 4 factorial. And now these two paintings, that is worst and best, can themselves be arranged in 2 factorial. Are you following? Right. So that's your answer. Okay. Worst and best have to be together. If they had us not together, then total minus, we could have done this. Are you following? Perfect. Now, moving on to the next one. Let's see this question. So we are given that arrange. So keep noting down the keywords over here. I'm saying arrange. So basically it says arrange 10 people. That means permutation in a line, so that 7 particular people are never together. So now what do we do in this case? arrange 10 people, 10 different people are there. So I can mention like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So out of 10 different people, because people are unique, isn't it? So they are distinct one another. Then it is saying that in a line, so that 7 particular people are never together. So never together means what? Total minus what I'll do. How to solve this? How many ways can these 10 people be arranged in a line? That is n factorial. So 10 people are there. So 10 factorial minus when 7 of them are together. So that means this is acting as one quantity, right? So this is one group. And then 1, 2, 3 plus 1. So 4 factorial. And then these 7 people can themselves be rearranged in 7 factorial ways, right? So we subtract this. Getting it? So this will give me the answer for basically when 7 people, but 7 particular people are never together. Getting it? So this gives me basically 10 factorial minus 4 factorial into 7 factorial. I hope it is clear to you. Okay. Does it make sense? All right. Now, moving on to the next one. Let's see the next concept. So next question is over here. It says there are basically 5 chairpersons. Okay. And it's given that the chief sits in the middle. Okay, so this is given to us that the chief out of these 5 chairpersons sits at the in the middle, right? Always in the middle, always. Or you could say middle can be replaced by the word center as well, right? So how many arrangements are possible? How many arrangements are possible? Are you following? So this is what we have here. Now, 5 chairpersons. So 5 dashes 1, 2, 3, 4, 5, right? So I can say the chief is fixed over here, right? So now remaining 4 people, right? They can be seated in 4p4 ways. So 4p4, which is nothing but 4 factorial, because all the 4, they have 4 choices, isn't it? And the order is important. So 4p4, which is 4 factorial. Getting it? So that's the answer. I hope the basics is clear to you, right? We'll be doing some more interesting questions based on concept in the next video. So stay tuned for the next video. Until then, thanks for watching and do share with your friends. Bye-bye.